right, hello. I'm here to work with the last activity in lesson 2 with you. So 2.3, a yearly gift. This is on page 83. And so the whole purpose of this activity is to be able to write a polynomial that has some meaning behind it. So this has to do with somebody graduating from college, or actually graduating from high school, and then her aunt is investing some money for her to get after she graduates from college. And so looking at a polynomial to represent that amount of money that she receives based off of X. So we'll talk about what that means. So it says at the end of 12th grade, Claire's aunt started investing money for her to use after graduating from college 4 years later. So we're going to assume that Claire only spends 4 years in college. The first deposit was $300. If R is the annual interest rate of the account, then at the end of each school year, the balance in the account is multiplied by some growth factor of X, so that X is equal to 1 plus R. And we're going to come back to the 1 plus R idea, but for now, understand every year that investment is multiplied by X. So if the money is only in the account for 1 year, it gets multiplied by X. For 2 years, X to the second. For 3 years, X to the third, and so on. All right. So after 1 year, the total value is 300X. So that initial deposit has been earning interest for 1 year. So then after 2 years, it will be that 300X times another X, or 300X squared. So then what about after graduation? Well, again, we're going to assume that she graduates in 4 years. So for that reason, we would say 300 x to the fourth. Our exponent is 4 because it takes 4 years to graduate from college. Now on number 2, if Claire's aunt had invested another $500, but now it's at the end of her freshman year, what would be the expression for the total value after graduation? So from the end of her freshman year to graduation, that's 3 years. So this is going to be 3 years. So this amount of money is only going to earn interest for 3 years. So the expression would be 500 x to the third. And we're multiplying. We don't need a multiplication symbol between a number and a variable. So 500 x to the third means 500 times x to the third. All right. Well, Claire's aunt sure is generous. So now, suppose that $250 was invested at the end of her sophomore year. So $250 at the end of her sophomore year, and then $400 at the end of her junior year. And that's in addition to what was already invested at her high school graduation and at the end of her freshman year. So this $250 is going to earn interest for all of her junior year and all of her senior year. And so that $250 is going to have its own expression of 250 x squared. Because again, it only gains that interest for 2 years. But then the $400 at the end of her junior year, that's only going to earn interest for 1 year. So that would be 400 x to the first, which is the same thing as just 400x. Okay, when our exponent is 1, we typically don't write it. Okay, So now we want to write an expression for the total value after graduation. So this is the total value after graduation. That's going to be all of those deposits and earning interest added up together. So we've got 300 x to the fourth. That's the high school graduation money, plus 500 x to the third. That 500 x to the third, that's the money at the end of her freshman year. It earns interest for 3 more years. And then plus 250 x squared. And finally plus 400 x. Okay? So this is called a 4th degree polynomial. The degree is 4 because that is the largest power of the variable. The largest exponent is 4, so it's called a 4th degree polynomial, and it has 4 terms. So each of these is a different term. Terms have different exponents on their variables, or different variable parts in them. So since this has got x to the 4th, and x to the 3rd, and x to the 2nd, and then just x, those are all different terms, and none of those are like terms, because again, they have different exponents on the variable. Okay, so now we're going to kind of shift gears here. I'm going to have you save this space, keep it blank for just a moment. The total amount y in dollars after 4 years is a function, and this is just a notation that tells us we can write this as a function c of x, and the growth factor is x. If the total Claire receives after graduation is 1,580, use a graph to find the interest rate the account earned. Okay, so what we're going to do, because we know that x is equal to 1 plus r, okay? So we're going to use a graph to figure out what x is, and then once we know what x is, then we can solve for r, which is the interest rate. Okay, so I've got Desmos set up on this screen, and you might notice I typed in the equation. So I've got 300 times x to the 4th. I was being dramatic by putting those parentheses in there. We don't need the parentheses, but I did put them in there. Plus 500 times x to the 3rd, plus 250 times x squared, plus 400 times x. So I'm going to go ahead and turn the graph on by clicking this little circle. And it looks awful. I don't even know what to look at in this representation. So I know I have to figure out when the function is equal to 1,580. So under the tool, I'm going to start by making the y's go up to 2,000. But maybe I'll start at like negative 100 so I can see. Oh, actually, I'm going to go to negative 500 because I can't really see in that part of the window. Okay. So now I can see, oh, it's going to be between like 0 and 2. So I'm going to change. So when I say it's between 0 and 2, I'm talking about on the x-axis, because 1,500 is right here. So 1,580 is going to be something between 0 and 2. So I'm going to change my x-axis to go from negative 2 to positive 2, and that just spreads it out really nicely. And now I can look at this more clearly. I'm going to put on, oh, I guess I already have it on, the larger font. Okay, So I could estimate, if I kind of click points here, I can see that's going to be $437. Over here, that's going to be $1,117. So I can just click here. This is getting closer. But if I want to find the actual value, I'm just going to type in y equals that 1,580. And it gives me a nice line. And I just have to click right here. And I can see an x value of 1.03489 makes the function equal to 1,580. I'm going to write that down before I switch screens. Oops, I missed a number. There we go. 1.03489. Alrighty. So let's go back to your workbook. I just wrote down the information. So you might want to sketch in a graph. So we made a graph and it does go through 0, 0. I'm only going to sketch in the first quadrant because that's what we were looking at. And it kind of went up like that. And then we graphed 1,580. And we found this point of intersection right there. Okay? And at that point of intersection, x was equal to 1.03489 and y was equal to 1,580. Okay, so this was our function, 300 x to the fourth plus 500 x to the third plus 250 x squared plus 400x. Oops. Okay. So the curve was the function that we came up with, this one right here. The straight line was just y equals 1,580. Okay, so these are the equations I typed into Desmos. I used a y equals for that one as well. Okay, so that point of intersection tells us this is our x value. So if x is equal to 1 plus r, that means that 1 plus r equals 1.03489. So to solve for r, take away the 1. R equals 0.03489. And in interest rates, we usually use a percentage. So we could say 0.03489 or 3.489%. All right, we're going to take a quick look at the lesson summary, and then you can work on your couple of practice problems that I have you doing. Okay, so lesson summary. Let's say we're going to invest $200 in annual interest rate of R. This means at the end of the year, the balance in the account is multiplied by a growth factor of X, which is 1 plus R, 1 plus the interest rate. After the first year, the amount in the account can be expressed as 200x, which is a polynomial. Similarly, after the second year, the amount would be 200x squared. After 3 years, 200x to the third, and so on. If an additional $350 is invested at the end of the first year, we can revise the polynomial. The amount of money in the account after 1 year is the same, but now the amount of money after 2 years is 200x plus 350, and then the quantity times x, or 200x squared plus 350x. So the first example is in factored form, which we'll talk about later in the unit, and the second is in standard form. What will the polynomial expression look like if $400 more is invested at the end of the second year and $150 at the end of the third year? So this looks a lot like the expression that we wrote for Claire. Okay, so this lesson summary is just going through what we just did again for reinforcement. Okay, so we have a function d of x, and d of x is going to be equal to the 200x to the fourth plus 350x to the third plus 400x squared plus 150x. And here's a graph to help us visualize. All right, so it says we can use this polynomial model to examine the effect of different annual interest rates, or to estimate what the annual interest rate needs to be to achieve a specific quantity. That's what we did with Claire at the end of the 4 years. For example, point A is at 1.04. And then this is where it says D of 1.04, the value is 1,216. Okay, so that would be like a 4% interest rate would yield $1,216. From this we know that the amount in the account after 4 years with an interest rate of 4% each year is approximately $1,216. Also, if we want the account to have $2,000 after 4 years, that corresponds to point B. So point B has the coordinates 1.25, 2,000. Okay, so this 0.25, that means a 25% interest rate, which that's an amazing rate. An interest rate of 25% will get you the $2,000 in 4 years. Let's see here. Though we're not likely to find a bank that would offer that rate. Note also that the values of x being less than 1 correspond to negative rates, so those are also unlikely. So we would kind of disregard any, because this would be like all of these values would give us something less than what was invested. Okay, polynomial models are adaptable to a variety of situations, even as they grow in complexity. So thank you for watching the video. Hopefully it gives you some ideas and you can reflect back on that as you're working as needed on your practice problems.